We're going to continue our lesson on section 5.3 on definite integrals and antiderivatives, looking at a few AP Calculus free response questions. In this first question, it's from the 2005 exam. It says the tide removes sand from sandy beach at a rate modeled by the function r given by r of t is 2 plus 5 sine 4 pi t over 25, and the pumping station adds sand to the beach at a rate of 15t over 1 plus 3t squared. So again, these are rates. So these are kind of like the derivatives, okay? And it says both r and t have units cubic yards per hour, and at time equals 0, the beach contains 2,500 cubic yards of sand. Okay, well, this is a calculator question, so the first thing we're going to do is we're going to enter these functions into our calculator. So let's just clear out any stuff I have on my calculator here. We're going to go to the graph mode, and the first function, it's going to be 2 plus 5 sine, and then it is 4xt, 4 pi t, sorry. What should you do? 4 pi x. Find my pi button here. 4 pi x divided by 25. Okay, and if I hit enter, I get a graph like that. And then my second function is 15x divided by 1 plus 3x. And that gives me my second function, which is something like that. Okay, so now let's go back to our calculate screen. And now our question says, how much sand will the tide remove from the beach during a 6-hour period? Indicate the units of measure. So in part A, they want to know how much sand will be removed. Well, we know the rate that the sand is being removed, so to find the amount, we have to integrate. And I'm integrating from 0 to 6 of my function r of t dt, which is the rate at which the sand is being removed. So this is straight to the calculator. Okay, so I am going to do a definite integral from 0 to 6. And I want to use my rate, which is r of t. So that one was stored as function 1. So I just hit the vars key, and it comes up as, and I hit function 1, and I have to tell it with respect to x, and I'm integrating with respect to x, and if I hit enter, I get a goofy answer like that, but again, I can just convert that to a decimal, and 31.816, so this equals 31.816 cubic yards. And for that question, in 2005, they gave you 2 marks. You got 1 mark for the correct integral, and you got 1 mark for the answer with units. Now, in part B, they want us to write an expression for y of t, the total number of cubic yards of sand on the beach at any time t. Okay, well, we have to read our question carefully because it says at time 0, there was 2,500 cubic yards of sand on the beach. So basically, to figure out the total amount of sand that's going to be on the beach, we start with 2,500. We're going to add the sand that's being pumped onto the beach by the pumping station, and we're going to subtract the sand that's being removed by the tide. So for this particular question then, to set this one up, it's really pretty straightforward. For part B, to find the total amount of sand, it's going to be equal to 2,500 minus the integral from 0 to some time t of the amount of sand added, and I'm going to just change the integral of my function to x because I have t as time, minus the amount that's removed by the tide dx. So there would be the equation for the total amount of sand at any time t. And again, for this question, they gave you 1 mark for the integrand, they gave you 1 mark for the correct limits, and they gave you 1 mark for the correct 2,500 minus the integrand. So this question was worth 3 marks. Okay, question C, they're asking us find the rate at which the total amount of sand on the beach is changing at t equals 4. Okay, well, to figure out the total amount of sand that is changing at t equals 4, okay, it's going to be y prime of t. And the y prime of t is really simply just our sand that's being added to the beach by the pumping station minus the sand being removed by the tide. So y prime of 4 is going to equal s of 4 minus r of 4. And if we figure this out using our calculator, this works out to be negative 1.909 cubic yards of sand. Question D now, if we look at the question, is asking us to just for time 0 to 6, at what time is the sand on the beach a minimum, and what is the minimum value? Justify your answer. Well, what we need to do here, first of all, is we need to figure out our critical numbers, okay? And our critical numbers are going to be where my derivative is 0. And we found that the derivative of y of t in question C was just s of t minus r of t. And we'll talk more about derivatives of integrals in section 5.4. Okay, so remember, absolute min either happens at the endpoints, which is at t equals 0 or t equals 6, or where the derivative changes from negative to positive. So if we go back to my graphing calculator, okay, the rate that it's being added is F2, and F1 is the rate that the tide is removing it. So I'm going to have to add a third graph here. So I'm going to get my tab key. And now I want to go function 2 with respect to x minus function 1 with, whoops, I forgot my subtraction key. Subtract function 1 with respect to x. So instead of retyping in the functions, I can just subtract the 2. And if I enter that, I get a graph that looks something like that. So now I want to change the window. So the window of my black graph is, I want it to go from 0 to 6, because that's what the question is saying, from the time 0 to 6. So there's my graph. So it looks like this is the graph of the derivative. I have a minimum right at this value right here where it changes from negative to positive. So I need to calculate or find that minimum value. So I'm going to use my calculator again, analyze graph. I want to find a 0. And I'm going to, it's asking me which graph. I want graph 3. And it says lower bound. I hit enter, upper bound. So there's my answer at 5.117865. And I want to store that because I can't round off yet. So to store that, I'm going to go control store. I'm going to call it variable A. And I'm going to hit enter. And notice it's highlighted now at 5.117865. So if we go back to finding our absolute max or our absolute min, sorry, we have, we'll make ourselves a little table here. So we have t, our time, and y of t. So we have time 0, time 6, and time a. And you would write somewhere on your paper that a was 5.117865. We know at the very beginning we had 2,500 cubic yards. So now to figure out the total amount of sand at A and 6, I'm going to go back to the equation I generated in B. So to figure out y of 6, it's going to be 2,500 minus the integral from 0 to 6 of s of x minus r of x dx. So using my calculator, Okay, I'm going to go back to the calculate mode. I'm going to get rid of this stuff. So I want, first of all, 2,500 plus, I want to do the integral or definite integral from 0 to 6. And then function 3, if you recall, that's where I had s of x minus r of x. So we're just going to recall that, so I don't have to retype it all in. And that works out to be 2493.2. Or 2493.28. So if we round it, that should really, we have to reset our calculator to change it to 3 decimal places. So I'll give you the 3 decimal place answer, and we'll worry about rounding the calculator off after. So 2493.277 is the 3 decimal places for that one. And now I have to do the same calculation for value A. So this is going to be 2,500 plus the integral from 0 to 6, or 0 to A. Of s of x minus r of x dx. So again, back to my calculator, it's going to be 2,500 plus the finite integral from 0 to 6 of function 3 dx, and that works out to be 2493 oh, I went the wrong thing. Sorry, I got to do that again. I got to do it to A. 2,500 plus the finite integral from 0 to, I want my variable a of function 3, my mistake there. And that's going to be 2492.369 if we went to 3 decimal places. So this is going to be 2492.369. Okay, so now let's answer the question. The question was, if we go back, at what time is the minimum, is the amount of sand on the beach a minimum, and what is the minimum value? Justify your answer. Well, my table justifies the answer because I checked the endpoints of my domain plus the critical number where it was a minimum. So we just write a final statement. We would say that the amount of sand is a minimum when T equals 5.117 hours, and the minimum amount of sand is 2,492.369 cubic yards. So again, I just want to go through an example here with you to show you how we can apply these definite integrals to some free response questions. Now there is some other questions similar. Okay, so I'm going to give you try this one on your own. You can do A, B, and C of this question. Very similar, but now we're talking about water being pumped into a tank and being removed from a tank. And there is another one as well, talking about mosquitoes. Again, we could look at all 4 questions there, and we'll cover both these in class. But again, I want you to give those a try on your own. So there's the assignment from the Calc 30 book and from the AP book for the first 2 videos of section 5.3. So give those a try, and if you have any questions, we can look at those in class.